Triangle ABC and triangle DBC are two isosceles triangles on the same base, and vertices A and D are on the same side of BC. That means we have two triangles with two equal sides, and the vertices of those triangles are on the top side of BC. So if AD is extended to intersect BC at P, show that triangle ABD is congruent to triangle ACD. Triangle ABP is congruent to triangle ACP. AP bisects the angle A as well as angle D. That means AP cuts both angles into two equal halves. And then AP is the perpendicular bisector of BC, which means that AP is perpendicular. That is, it is at 90 degree to BC, and also it cuts BC into two equal halves. This is what we have to show. Welcome to Math-o-tropism. So the first step is understanding what is given and identifying those concepts. So we have been given that triangle ABC and triangle DBC are two isosceles triangles on the same base. That since it is isosceles, two sides must be equal. So AB is equal to AC and DB is equal to DC. Similarly, we have been given that AD is extended to intersect BC at P. So we need to show that triangle ABD is congruent to triangle ACD. Triangle ABP is congruent to triangle ACP, and third one is AP bisects angle A as well as angle D, and fourth one is AP is the perpendicular bisector of BC. Now what does the third one mean? It means that angle BAP is equal to angle CAP, and similarly with the fourth one says that AP is perpendicular to BC, which means angle APC and angle APB both should be 90 degree, and since it's a bisector, it means BP should be equal to PC. So we need to prove this. So first, since the congruent triangles have been given, we will start with the first one. We'll take triangle ABD and triangle ACD. From the first step, we can see that two sides are equal. That means AB is equal to AC and DB is equal to DC, and we can see that AD is the common side. So directly all the sides are congruent. So as a result, by SSS congruence, we can write that triangle ABD is congruent to triangle ACD. When we take AB and AC, we have B and C to be the corresponding vertices. That's why instead of B, we have written C. Similarly, if this is congruent, it means by CPCT we can show that angle BAD is equal to angle CAD, which is nothing but angle BAP is equal to angle CAP. So since both the angles are equal, it means my line AP is cutting my angle A into two equal halves. Therefore, we can write that AP is bisecting angle A. Next, when we see, we can also see by CPCT that BDA, angle BDA is also equal to angle CDA. So it means if these two angles are also equal and we take AP as a straight line, then we can write that angle BDA plus angle BDP is equal to angle CDA plus angle CDP. Both will be 180 degree because AP is a straight line. So since we have already shown that BDA and CDA are equal, it means that angle BDP and angle CDP are also equal. So it means AP is also cutting the angle D into two equal halves. Therefore, we can say that AP is bisecting both the angles A as well as angle D. That is the third one which we have shown. Next, we'll go to the second one which we have to prove, that is triangle ABP is congruent to triangle ACP. Now, when we see this from step 1 and 4, we can see that AB is equal to AC. AP is the common side, and we have already shown that angle BAP is equal to angle CAP from the fourth step. So it means we have two sides equal and the included angle as equal. So by SAS congruence, we can write that triangle ABP congruent to, instead of A, we have the angle A. So first, with respect to angle only, we'll write the corresponding vertex. So A and A are corresponding vertices. When we see AB equal to AC, since A angle is the same, it means that B corresponds to C vertex and P corresponds to P itself. So as a result, by SAS congruence, triangle ABP is congruent to triangle ACP. We need to prove the last one. We'll take these two triangles itself, and by CPCT we can write that angle BPA is equal to angle APC, also BP is equal to PC. So it means what? AP is bisecting BC because BP is equal to BC. Also we know that BC is a straight line, and we have shown that both angles BPA and APC both are equal. So it means what? Since it's a straight line, it is 180 degree. So as a result, twice of angle BPA is 180 degree, which means that angle BPA is 90 degree. It means what? AP is perpendicular to BC. So as a result, AP is the perpendicular bisector of BC. Thus we can show. Next step is forming equations and solving the sum. So given is ABC and DBC are isosceles triangles, which means AB is equal to AC, we'll keep as equation 1, and DB is equal to DC, we'll keep as equation 2. We need to show that triangle ABD is congruent to triangle ACD, triangle ABP is congruent to triangle ACP, and AP bisects angle A as well as angle D. That means angle BAP should be equal to angle PAC, and similarly AP is the perpendicular bisector of BC, which means that angle BPA is equal to angle APC. Both will be 90 degree, and also BP is equal to PC. So we'll start with the solution. We'll take the triangle ABD and ACD. From 1 we have that AB is equal to AC. From 2 we have DB is equal to DC, and we can see from the figure that AD is the common side of both the triangles. So by SSS congruence we can write the triangle ABD is congruent to triangle ACD. So by CPCT we can show that angle BAD is equal to angle CAD, which is nothing but extended till P. So which means angle BAP and also angle CAP both are equal. So we'll keep as equation 3 since these two angles are equal. That means the angle A has been cut into two equal halves by AP. Therefore AP bisects angle A. Similarly, we'll take the other angle with respect to D. So angle BDA is equal to angle CDA. We'll keep as equation 4. And angle BDA plus angle BDP is equal to angle CDA plus angle CDP, which is equal to 180 degree. Why? Because AP is a straight line, so both these angles make a linear pair. So from 4 we can write that angle BDP is equal to angle CDP. So here also AP is cutting the angle D into two equal halves. Therefore AP bisects angle D. So we have shown that AP bisects both angle A and angle D. So next we will take the triangles ABP and triangle ACP. Again from 1 we have AB equal to AC. From 3 we can see that angle BAP is equal to angle CAP, and then AP is the common side. So by SAS congruence we can write the triangle ABP is congruent to triangle ACP. So by CPCT we can show that angle BPA is equal to angle CPA. We'll keep as equation 5, and we also know that these two angles make a linear pair. So angle BPA plus angle CPA is equal to 180 degree because BC is a straight line. So from 5 we can write that twice of angle BPA is equal to twice of angle CPA, which is equal to 180 degree, which means angle BPA and angle CPA both are 90 degree. Since both are 90, it means AB is cutting BC at 90 degree, which means that AP is perpendicular to BC. Again, from the previous step where we had shown that triangle ABP is congruent to triangle ACP, we can show by CPCT that BP will also be equal to CP, where we are taking the last two vertices at a time. So that is AP is bisecting BC, which means AP has cut BC into two equal halves. So from 6 and 7 we can show that AP is the perpendicular bisector of BC. Thus shown. Thank you.